Hey everybody, I wanted to take a quick look at a few different methods of pitch correction and what kind of artifacts they might introduce into an audio signal. I actually took interest in this idea a couple years ago, but I wound up getting busy and running out of time, and I lost a couple of my examples, so I'm pretty much starting from scratch. But I do want to give a shout out to Tobias Gehring for reigniting my interest in the subject, so thank you for that. Jumping right into it, we have a 220 Hz triangle wave at -6 dB FS. What this gives us is a nice harmonic rich sound source to use as a baseline for comparison. This was generated in Adobe Audition 3 at 192 kHz and downsampled to 48 kHz, and I did that to make sure that there's no potential sources for aliasing down the road. We also have a 225 Hz triangle wave generated the same way, and this is what we're actually going to be processing. This is about 40 cents sharp of A220, so it's not really extreme pitch correction, but it's enough that you would definitely notice it. So our first example here is Solemnity Melodyne. This is the newest version as of recording this video, and the result kind of surprised me because our peak is -6 dB FS, and we start seeing noticeable artifacts around -72 dB FS. And I think it's interesting to note that this is not harmonic distortion like you would get in some kind of analog saturation or clipping or anything like that. This has a lot more in common with jitter from a digital system. It sounds like a general lack of clarity. I think it's interesting to note that people go out of their way to get the best possible analog to digital converters, and then they run it through pitch correction and wind up with these sideband artifacts, which are similar to what you would get from 1970s analog to digital converters. We're doing our measurements in Adobe Audition, so we might as well try their pitch correction, and the results are very similar to Solemnity's Melodyne, except we actually do have some harmonic distortion here. We have a 4th order and 8th order. It continues on up the spectrum. Our next example is G-Snap. This is sort of like a freeware version of Vanteri's Auto-Tune, and this is actually really surprising to me. I'm surprised at how clean this is. There's noticeably less artifacts than with the other two examples. And unfortunately, I don't have the Vanteri's Auto-Tune example anymore, but I do remember it being somewhat higher than this. For kicks and giggles, I took our 48 kHz waveform and slowed it down to about 97.8% and then resampled it back to 48K. This gives us very similar results to our original 220 Hz reference. I also tried the time stretch method. This essentially internally slows down and resamples the audio, and it's not quite as clean as doing it as an offline process, but we definitely don't have the sideband artifacts like we did with the traditional pitch correction methods. Now, in the early 60s, we had something called an information rate changer, which was a little device that allowed you to change the pitch of a tape without changing the speed, or changing the speed without changing the pitch. And it was used in Star Trek. It was used in 2001: A Space Odyssey for some various vocal effects. And that was kind of the beginning of being able to fix notes artificially. And by the late 70s, we had digital pitch shifters, which made it a lot easier. When people sing out of tune, they generally tend to be fairly consistently a little bit flat or a little bit sharp. So I would just split the track and run it through a pitch shifter. And whenever I got to a note that sounded like it was a bit too iffy, I would just switch to the pitch shifted version. And just looking at Vegas's pitch shift, we can see some interesting little side bands. They're less than what you saw in the actual pitch correction programs, except for G-Snap. But you also have more manual control over this, so it's kind of an interesting little give and take thing. Looking at Adobe Audition's pitch shift, this is a horrific mess. So the quality of your pitch shifter definitely makes a huge difference. And really, most of the time when I have to do some kind of pitch correction, this is how I do it. I did have another example, RBC Voice Tweaker. It really introduced a lot of audible artifacts, more so than any of the others. So I'm really surprised at some of the results here, particularly how much the difference just the algorithm for a static pitch shift can make. Anyway, I hope you learned something, and be sure to like, share, and subscribe.